Hello students, I hope you're all doing well. Welcome to the first video of our comprehensive GCSE Chemistry playlist brought to you by QuickStudy. In this series, we will try to cover all the essential topics that are required for the exam. So let us get started. The first chapter that we will cover is states of matter. There are three states of matter: solids, liquids, and gases. Usually, a substance can exist in all three states depending on the temperature and pressure. So let us take a look at the characteristics of solids. In a solid, the particles are arranged regularly and are packed closely. The particles in a solid have the least energy compared to particles in the other states. The particles are only able to vibrate in their fixed positions. The particles in a solid have strong forces of attraction holding them together. Finally, solids have a three-dimensional shape. Now, let us move on to liquids. In a liquid, the particles are irregularly arranged with more spaces in between them than in solids, but are closer together than in gases. The particles in a liquid have more energy than solids, but lower energy than in gases. The forces between the particles are less than in solids. The particles in a liquid can slide past each other and move throughout the liquid. Liquids take the shape of the container that it is stored in. So, what about gases? In gases, the particles are randomly arranged, and the particles are the furthest apart compared to solids and in liquids, with large spaces in between them and almost no forces of attraction. The particles in gases have the most kinetic energy than those in other states and are therefore able to move about freely in the container they are stored in. Gases do not have a shape. Now, let us take a look at the interconversions between the different states of matter. The process involving the change of state of a substance from solid into liquid is called melting. When a solid is heated, heat energy transformed into kinetic energy absorbed by the particles, resulting the particles to vibrate faster about their fixed positions. When the temperature is high enough, the vibration of the particles becomes sufficient to overcome the forces of attraction between them that are holding them together, and therefore the particles can now move around more freely, and thus the solid melting into a liquid. The temperature at which a solid melts into a liquid is called the melting point. Now, let us take a look at the changing of state from liquid into a solid. The process involving the change of state of a substance from liquid into solid is called freezing. The whole process is basically reversed. So when a liquid is cooled, energy is given out by the particles, and thus the particles begin to move slower as a result of lower kinetic energy. When the temperature is low enough, the particles no longer have the energy to slide over each other. The forces of attraction between the particles are now able to hold the particles into fixed positions, and thus, as the particles are settled, the substance's state becomes solid. The temperature at which a solid melts into a liquid is called the freezing point. The diagram here summarizes the two processes that have been discussed. Although they are called different things depending on the direction of the change of states, the temperature of the melting point and the freezing point of a substance are exactly the same. Now, let us look at the changing of states between liquids and gases. There are two different ways that this happens: boiling and evaporation. Boiling involves changing the state of a substance from liquid to gas. When a liquid is strongly heated, particles gain kinetic energy and move fast enough to overcome the forces of attraction between them. Bubbles of gas start forming below the surface of the liquid, allowing the liquid particles to escape from the surface and from within the liquid. The particles escape as gas particles. The stronger the forces of attraction, the higher the boiling point of the liquid, as more energy is required to overcome the forces of attraction. The specific temperature at which a liquid boils into a gas is called the boiling point. Condensation is the process by which a gas turns into a liquid. When a gas is cooled, particles lose kinetic energy and eventually move slowly enough that they can bounce away when they bump into each other. The forces of attraction between them start to form and hold the gas particles together as liquids. The gas, therefore, condenses into a liquid. The specific temperature at which a gas condenses into a liquid is called the condensation point. The boiling point and the condensation point of a substance occurs at the same temperature. Evaporation also involves changing of a liquid into a gas, but at a temperature below the boiling point of the substance. In any liquid or gas, the average speed of the particles vary with temperature. However, at each temperature, some particles will have higher energy than average and will move faster, and vice versa. Some of these high-energy particles at the surface of the liquid will have enough energy to break away from the surface to form gas at low temperatures below the boiling point of the liquid. The larger the surface and the warmer the liquid, or the surface, the more quickly the liquid can evaporate. Evaporation occurs at a range of temperatures, but heating will speed up the process as particles need energy to escape from the surface of the liquid. In a closed container, gas particles will collide with the particles at the surface of the liquid and become part of the liquid. In a closed container, the gas particles will collide with particles at the surface of the liquid. The gas particles that are moving slowly enough will be held by attractive forces and become part of the liquid. Therefore, in a closed container, evaporation and condensation occur simultaneously. Now, let us take a look at the key differences between boiling and evaporation. Boiling occurs at a specific temperature called the boiling temperature. Evaporation occurs at all temperatures above the melting point and below the boiling point of the liquid. In boiling, there is bubbling from below the surface, and the particles escape from below the surface of the liquid. In evaporation, however, there is no bubbling, and the particles escape from the surface of the liquid. Sublimation is the process by which a solid directly turns into a gas at normal pressure without involving any liquid in the process. This only happens to a few solids such as iodine or solid carbon dioxide. Solid carbon dioxide, also called dry ice, turns into gaseous carbon dioxide at minus 78.5 degrees Celsius. The reverse process, that is, conversion of a gas into a solid directly, is called deposition. Here we have the heating curve of water. Water exists as ice at temperatures below 0 degrees Celsius. As ice is heated, the temperature increases. At 0 degrees Celsius, change of state occurs as solid ice melts into liquid water. As the water is continued to be heated, the temperature increases. At 100 degrees Celsius, another change of state occurs as liquid water is boiled and it forms steam. Now, the reverse process occurs when the temperature is decreased. The reverse process occurs when it is cooled. When steam is cooled at 100 degrees Celsius, the gaseous steam condenses into a liquid water. As the liquid is further cooled at 0 degrees Celsius, the liquid water freezes into ice. This brings us towards the end of the video. In this video, we covered the different states of matter and how the interconversions between the different states take place. In the next video, we will cover the topics of diffusion and solubility. Thank you for watching this video. If you have liked this video, do subscribe to our channel as we post regularly about the different subjects and topics that will help you ace your GCSEs. Also, for more information on our one-on-one tutoring services, do visit our website www.quickstudy.uk. Thank you.